All right, so with the eVscope in a ready position, what I'm going to do is move it to be 90 degrees. I'm at the end of the Quonset. I've got my artificial star on the other side. Okay, you can do rough approximation because our first step is actually going to be to remove the mirror cell and clean it. In this case, the mirror cell looks not horribly, not horrible. It's not too dirty. So that's a good sign. But we're still going to take it out for the purpose of this demonstration and have a look at it. Now, I don't remember what telescope tool in particular, but there are only a few of them, so literally a couple, to be honest. So if one doesn't work, try the other. In this case, this one works. It's the hex and not the star, which makes sense because in collimation you want the star, which gives you a little more precision. So with this hex, I'm going to go through and remove all 4 of these screws. I should also note, before you go and move this, take note of the focuser in the back of where you were at the starting point. You'll notice that there's measurement notches here, and they only go, 3/4 of the way around. So, what I do here is, start from a known place like this screw here, and then count over your notches roughly. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at about 10 notches, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so let's recount. Let's try this again. So from the screw, we'll come in and we'll start with this guy. So we have 1, 2, 3, 4. So about 13 notches from the screw in this position, which is roughly about, I'd say that's a 2 o'clock position. So something to keep an eye on the positioning that this was focused on, so that when you reassemble this and you're done collimating, because the Quonset is not far enough, you're never going to get a perfect focus back in the Quonset. So because other people will use this scope, not a bad idea to remember your focus position when you started and then get it back into a rough focus position, because then people are able to find focus once it's out in the field. So now what I'm going to do, make note of these 2 collimation screws, the position that they're in, 12 o'clock and 9 o'clock. And now I'm going to go and, kind of like you do with a tire, don't apply too much left pressure to open. At any given time on one side, kind of disperse it. Open the mirror cell by removing these 4 hex screws. We'll continue. All right, now that we have the mirror cell, you can see all the dust that's on it and the dirt of overtime use. So what we're gonna start off by doing is just light, kind of blow off the dust with a hand bulb. After that, we're going to use a very very soft microfiber to apply some motion on here to get off the dust particles. Okay, now this kit is very basic, so I recommend starting with something simple, which is soapy water and basically some spot-free water rinse. So this is essentially the kit. It comes in two parts: a cleaning solution from Universal Astro, and then a spot-free rinse solution. So what we're going to do is not spray anything direct on the mirror cell itself, because as you can see, it's positioned in plastic, and if we spray the mirror cell, things are going to get all over the place, and we really just want to clean the mirror. So I'm going to spray on my very, very soft, comes with this kit, microfiber. Make sure to keep yours washed or cleaned, whatever. And we're going to find a nice soft spot. I'm going to spray it, wet it down, and we're going to work on the mirror a little bit. And so what I'm going to do is just go in a circular motion with the cleaner solution applied. Very gentle. I'm not trying to apply too much pressure or force. You can see how maybe it's hard to see because everything's reflective, but essentially you're going to have basically, it's hard to do this one-handed, but a little bit of a residue from the cleaning solution that's getting applied. That's just fine. Once it's wet, you kind of use the other side of your microfiber to dry off those wet areas. I do like to use a circular motion. Very, very light. All right. Hard to see from this angle, but essentially I've done circular motion and done a very light clean. There's still some finer particles, so I'm going to do one more time, and then I'm going to apply the rinse solution and dry it again. All right, now I'm just applying the rinse. And then I'm going to dry. If anything seems stuck, don't force it. Just come back to it. There'll be a little bit of dust on here, so just get the finer particles off. It doesn't need to be perfect, but it's already far better than it was when we started. Okay, so that looks pretty good. And so what we're going to do is put it back together. Now, if you remember the order that you put this in with the collimation screws facing top and to the left, then this is pretty easy to reassemble. So there will be no force. It won't be hard. You can see how the back goes in, and align. There's screw holes right here. So just make sure to align your screw holes together, and then it slides right back in. So there shouldn't be any force. You won't have to apply any pressure. If you are, don't force anything. Back out and make sure that you've got the orientation correct. So you have your collimation screws looking as I do here with the center screw, and then the eyepiece is dead center with that center screw. The center screw being right here. Collimation screw right there, right there. Eyepiece, of course, right up there. So I'm going to tighten down, and then I'm going to take it through the collimation process. All right, for collimating the eVscope after you've gone through a cleaning on the mirror, what I'd like to do is use the tripod at the front of the MAS. Sometimes you could also use the top of a tabletop because these tables at the MAS Quonset are standardized. So you use this table or you use this tripod, whichever one works. You also have to have an artificial star. So you can get artificial star online through, AstroZap is one I have at home. Alternatively, you could use something like this, which is cheaper and produces artificial stars as well. So Hubble Optics is the version for the flashlight. Now, if you use the tripod version, the benefit is it has a very consistent light that comes through at the front. So once you're positioned, you want to bring the tablet to you, obviously, to help in positioning. You can use laser pointer as well to help, from the location of the Unistellar eVscope. Or just shine a laser pointer on the wall and you can collimate off a laser pointer as well. So these are two options you can use. Now notice I'm set up at the front of the Quonset with my tablet. And all the way back in the dark is our cleaned MAS eVscope mirror. So we have the eVscope set up, all nice and clean, and it's pointing horizontally. It's turned on. So you can see here, turned on, horizontal position, and then pointing toward the front of the Quonset where I have the artificial star. You'll notice I have it in this way anyway, or on this, you need to point the MAS in this direction, the MAS eVscope in this direction, because you need to take the mirror off to clean it. So the mirror can be taken off by using hex bolts. There are 4 of them, like that. And then when you do take off the mirror to clean, you just want to make sure to remember the orientation of how it was. So the way that it is currently is we have your collimation screws, which are here and here. Focus knob here, I'm defocused right now. And then your order of your bolts. So basically you want to have the 2 collimation screws facing kind of outwards where the eyepiece is. So it's a good way to remember it, but turn off the lights and collimation will take place back here. Notice there's tripod tools and there's telescope tools. So we're going to be using the telescope tool for collimation, which I believe is number 1, but you'll find out very shortly if it's not. And so in the light here, I'm going to show you picking a tool. Let's find out together. And what you're wanting to do is make sure that your tool here fits. It's a star, and it does. So this is the tool that we'll use for collimation. If you're wondering where these tools are, they sit in the bag, which is right here, along with our grading filter and some other more advanced tools, and then we put it in the back right there. So I'm going to take us through the collimation process next. Okay, so now we have the eVscope set up. Okay, so now I'm going to do the same process with the eVscope. I've got my tablet set up here. I have now got my artificial star in sight, which you can see actually for the EV2. I learned my lesson and put this higher rather than lower, since it's easier to go up than down. Now, roughly that's about, you want it equal, not higher than the scope level, so that's pretty good. Essentially, we don't need to be perfectly aligned, but you can see here the scope here is pointing toward the artificial star, which is over there. It's very dim. When I turn out the lights, you might be able to see it, but it really doesn't take much. So that's all. That's all it is for an artificial star. And now, if I zoom out, you barely see it over there. You also can barely see the back of your telescope, so use have a light with you, or maybe the glow of the collimation pattern. And then we have a little work to do on this collimation pattern. So again, make sure slow-mo is set. Move it always toward the center before you start any work. And in this case, I'm going to aim to move the bar here down just a touch and to the right just a touch. So because every time you touch this the first time, it always goes the way you don't want it to go, right? So make contact with your collimation screw, and you'll notice making contact budges the view a little bit. So if you moved it out just by jostling the collimation screw, move it back into the center. See here, I can't, but my hand is ready to go on the notch. I'm going to be as delicate as I possibly can be, and remember the direction I turned. So here I went right. You can see when I apply pressure, this is hard to act on, so I'm going to again nudge the scope just slightly the opposite direction that I want to go. And if you want to get the other stuff out of the way, just tap the screen. So, all right, so now I'm going to work on this, repeat the same process. Okay, and we've got it collimated to a point that is probably safe to stop for now. You can nitpick this endless ways, but suffice it to say that you reach a point where it's about as good as you can get it for the time being. So that's what we're looking at. It's about as close as we can get it. We could probably bring the center bar down just very, very slightly since the bottom is a little larger. All right, that's where I'm going to leave it for the night. So this is now collimated as best as I can for the night. And what I'm going to do is put it back in the focus position that we remembered at the beginning of this video. And then I'm going to call it a night. So that's how you collimate the eVscope. Looking here is we're looking for a pattern. This cross on the defocused image should be dead center in the middle. So, actually we've assembled it pretty carefully and it's not too bad, but what you want are the pieces of the pie to be equal on all sides. And you also want to make sure that this image is centered in the screen. So what we're going to do is set this down. We don't want to be moving much, so we're going to sit so we're steady. The Quonset floor does jostle a little bit, so keep your weight consistent. All right. And make sure you can access the back of the eVscope to do this. It's pouring rain as I do this, so that's fun. Just goes to show you can collimate scopes even when it's raining. All right, so before I get too involved with starting, what I'm going to do is make sure that I'm pinched to zoom so that I'm zoomed all the way out as much as I can be. And then I'm going to center the image in the center of the screen. Make sure slow mode is blue highlighted so that any of your movements are going to be subtle. You always want to keep this in the center of the screen. So let's start. So remember airplane mode, airplane controls. So if you want to go, you move the joystick left and it goes right. So notice how we're starting to see the pattern a little bit change. So now, oops, wrong way. Okay, so what we're at right here, and we're gonna leave it for now, it's fine, but is we're already, what this is indicating, because I can't get this shape any higher on the screen, it's indicating we would start to go below the horizon if we continue to move this. So we can't do that. So the solution here would be to raise the artificial star just slightly so that it's a little higher up. So I'm going to go do that right now. Okay, so I've now moved the telescope so that we can actually, or I've not moved the telescope, I've now moved the artificial star on the tripod a little higher so that I can actually get this centered in the center of the screen. So we're going to continue where we left off by doing that. Okay, now what we want to do is get this pattern so that all parts of the pie are equal distance. So you can see that, for example, the top left is a smaller part of the pie, and the bottom left is a little larger, and the top right is squeezed a little bit. So I'm going to do some adjustments in the back to update the pattern just slightly. So what I would say is the way that I'm set up here. Oops, let me get the lights on. There we go. Let's, you have a look. I'm sitting back here on a chair, and I've got the tablet beside me. So it's a comfortable spot. I'm not going to move a lot when I collimate. And I've got my wrench in my hand here, and I'm going to basically, oops, let me just get this to the right. Yeah, here we go. So what I'm going to do is just turn this only so slightly. Remember which direction you turn, and it's only a slight nudge. Okay. So I turn left, one strong turn. So now I'm going to look at my screen. It's a little off center, so I'm going to center it again. And I turn left, one strong turn, but what I really mean is, oops. Okay. And what I actually did is turned about a quarter turn. So what happened here is it went out of the field of view, so I'm going to readjust, and we'll work on this one at a time. Okay, I've adjusted further, and what I've realized is the top left was actually making it worse to do a quarter turn. So I've gone back my quarter turn. So remember how many turns? And by a quarter, I just mean like that. That's all. So just remember what big of a difference that made once you center again. And if you went the wrong way, go back to cancel out the same action, and then go the other way to try again. So what I'm going to try to do here is do one more quarter turn clockwise on the top. Okay, so now I think I'm going to do about as much work as I want to do with the top screw for now. I'm going to go after now the bottom left screw on the telescope. So we talk about top and bottom. Essentially, I was working on turns on this top screw right here, and now I'm going to use this screw over here at the 9 o'clock position. I'm going to try a left quarter and see how that starts, and we'll go from there. Okay, we've got it a little better now. This has taken about 5 minutes of going back and forth. What I'm going to spend a little more time on here is to, make sure that the cross is making its cross as close as possible to a center line as I can. So right now it's just fine tuning is what's needed, but yeah, I think visually we can see that the bottom two pie pieces are still a little bit larger. So I'm going to move in that direction just slightly. Okay, so sometimes after you're doing this for a while, you kind of have to hit a stopping point, otherwise you can be here all day. One thing that I like to do to get a rough collimation going is you do this over a course of many nights, so I have the luxury of doing that when I'm at home. However, when you're at the MAS, you're only here for a set amount of time. So what I think a good rule of thumb, though, is if you can calculate from the top of the circle, you essentially want to hit the very peak of the circle. And then you want to cover the peak halfway point of the circle. So as long as your lines are as close to the very peak and as close to the very center as possible, sometimes you have to just call it a good day. So right now, I'm going to leave it like this. This is showing a little bit like I could go a little further down with the center bar because these two pies are a little too small as opposed to the larger. You could actually measure your screen if you want to get crazy with this. Or you could use a frame of reference outside of your screen. But generally speaking, you could do what I'm doing, just use kind of your tool at a set distance and confirm that the size of the pies is roughly the same. So what I'll do is I'll give this one more nudge because I think there could be a little more out of this still. And my nudge is going to be to basically move the center line down just a little bit, just a smudge down, because my bottom pie pieces are a little larger. And I'd like to move this center one just a smudge over to the right. So still gonna keep working on this. All right, so with all this done, this video is short, but actually it took about an hour to complete the process, hour and a half to clean. So it does take some patience. You're never going to be happy with the final result, but I think that this is probably as good as we're going to get it. Might move the bar down just still a little bit more, but I think I'm going to leave it as this. So if you can get it to this state, you're generally going to be okay with your type of images that the eVscope will produce. Generally speaking, again, you're wanting to get all these pie pieces the same size, and you want to get the lines that cross as close to a center middle as you possibly can. So before I wrap up for the day, what I'm going to do is put back in focus and hopefully it will reach focus. It might not, because our star is actually our artificial star is pretty darn close. Sorry, wrong direction there. I will try to put into focus here and see if we can do it. Like I said, we might not be able to because it's pretty close. Yeah, it's pretty close. But let me keep futzing with it, and we'll get it back to a good state. If there are any questions on anything going on with the eVscope, contact somebody at the MAS who is familiar with them. Myself is a good person to contact, but if you can't reach me, just reach out to the Google group at Milwaukee Astro at googlegroups.com and ask for help. Collimation is not something you want to attempt if you've never done it before. So this video is more designed for some of our caretakers of the eVscopes, as well as some of our owners of the eVscope, to understand how to collimate and troubleshoot, including collimation when it's actually cloudy out. Quonset provides a good platform for that with the use of an artificial star. If you don't have an artificial star, a very dim laser pointer will work. It's just the problem is you want to get it steady on the other side so it doesn't shake. Alternatively, if it is clear after you after you clean the mirror, what you can do is take the telescope out, go to a medium star. It doesn't have to be, you don't want anything that will blow out the telescope like Vega, but you also don't want something that's super dim. So honestly, Polaris will work just fine. The only problem with Polaris is it's a double. So if you can, try to get a single star or at least a medium brightness star. Once you do that, then you can defocus. And the goal is to, when you defocus as much as you can while you still have the circle in the defocused ring in the field of view. You want the whole thing. And then you want to make sure that it's dead center every time before you do any calculations or any adjustments, rather, not calculations. With that said, put it back into focus position and you should be good to go. We do want to keep the telescopes in focus position because it helps some of the new people who are just learning the focusing techniques with the mask to not fail at the first plate solve. The eVscope has a tolerance for out of focus plate solving, but within limits. If it gets too far, you need to focus for plate solving to work. So, all right, thanks for watching.